I will explain about the section 1.10. This is about the log function, logarithma function. Okay, what is a log function? Okay, basically, when we're talking about log function, the general form for the log can be written as y equal to log b log y equal to log base b of x. In y, we can write this as y equal to log with base b. B is a base for log of x, or we can also say y equal to log bx. B is a base for this log. Y again, y is a range, and then y is output. X is also input or domain. Okay, but for basically there is a relationship between log and exponential. If you can see here, if fx equal to b to the power of x, the exponential function base b, then the inverse function of exponential is called the log function base b, and it that we can write this equal to log bx. So there is a relationship between these two type of functions, between log and between the exponential. So again, when y equal to log bx, okay, I show you here how to with this equation. They say log is for y equal to log bx. Here I use the black. Y equal to log bx. For example, y equal to log bx. And then if y equal to log bx, the exponential function, the inverse function for this log is exponential. So for this function, this log function can also be written in the exponential form in like this. So if y equal to log bx, x equal to b to the power of y. And that is the connection between these two functions. The log function and these two equations can be written in the log form or in the exponential form. So again, when y equal to log bx, the exponential form of this log is x equal to by. For example, you can refer to page 46. You can refer to the page 46, and then table example 1.37. Let's say we have the log form is y2 equal to 2 equal log 525. So this is the log form, is the exponential form is 25 equal to 5 to the power of 2, 5 to the power of 2. So let's say we have another let's say 0 equal to log 10 of 1, log with base 10 of 1. So the exponential form is 1 equal to 0 to the power of 10, 10 to the power of 0. The connection. And then if you go, we have another one. Let's say negative 3 equal to log 3 to the power of 1 over 27, for example. Okay, the exponential one is equal to 1 over 27. This is a 3 to the power of negative 3. Okay, this is equal to 1 to the power of 3, 1 over 3 to the power of negative 3. That's the relationship between the log and the exponential. Okay. actually, when we write the n equation in a log form, what does it mean? Okay, what does it mean by, let's say, I just take one example here. Let's say this one. Okay, I have this expression again. Uh, Log 525 equal to equal to, and then we have log 3 of 81 equal to 4. Okay. Um, Log 525, log 5, log with base 5 of 25 is 2. That means, uh, what does it mean by this log? How to explain? Why when we find the log, why log 5 of 25 is 2? This log show that we tell us about, in other words, we want to know what power I do have to waste 5 to get 25. Okay, right answer. What power I have to waste 5 to get 25? Of course, the answer is 5 to the power of 2. We need to raise the power of 5 times, 2 times 5 times 5 equal to 25. That's log. In other words, let's say log with base 3 of 81. In other words, we can say, we can ask what power we do have to waste 3 to get 81. The answer is 4. So this is equal to 3 to the power of 4. This is equal to 3 times 3 times 3 times 3 equal to 81. That's log 381 equal to 4. We have to raise to the power to the fourth power to get the value of 81. Meaning that we have to times 4 times 3 times 3 times 3 and times 3, or 3 to the power of 4. That's the exponential to get the number 81. That's all. That's about uh, the log. How the log how we can use log to explain the exponential form. And of course, there is in this example show that there is a there is, of course, that there are the close relationship, the strong relationship between the log and the exponential. Okay, I hope you can follow me. If you have any question, just let me know. Okay, the next one, if you refer to page 46, let's say you refer to page 46. Okay. Uh, okay. The next one, uh, I will explain about the base of the log. Okay, basically, when we write log with the base 2, uh, uh, let's say y equal to log of with the base 2 of x. And it is a log with base 2. Or we have a y equal to log of base log with base 5 of x, for example. Okay. But we also have a log with this form, y equal to log with base 10 of x. Y equal to log of log with base 10 of x. Okay, this log can also be written as y equal to log x. Okay, this equation where there is no base here also refer to the log with the base 10. So again, when we can write log base 10, log base 10 of x can also be written as log x only. No need to write the base, because in log the common log. We call it the common log. Log with base 10 is also known as a log only. That's why when you have if you see on your calculator, there is a two button here, log button and LN button. The log button is for log with base 10. And then the second button, the second one is about the natural log. Natural log. And there is this one is common log. One is for common log. The second one is for natural log. Okay, this one is for natural log. Okay. Okay. Just wait for a few minutes. Just wait for a few minutes. Okay. What? Okay. Natural log. Before this, we have a common log. Common log is y equal to log 10. Can also be written as y equal to log x. But natural log is about the log with base e. Log uh, uh, log base e of x can also be written as ln x. Ln x is a natural log or log with a base e. That's why in your calculator, when you see your calculator, there are two buttons on your calculator. Log with a base e is have a ln. You have a must there are ln button. That's log for base e, and log for base 10 with base 10 is they are log button and log button, because that button is for log with base 10 for the common log. So in other words, if I write y equal to ln 10, this is also to y equal to log e of 10, because there are two connection here. Okay. For example, okay, let's see for just see for the few example here how to solve the equation of log. Okay, there are few example I will share with you. Let's say okay, before that, if you see uh, on page 47, if you can see the page 47, there are few properties for log. This property is very important when you want to use the log in your calculation. Okay, but in this class, I will not ask you to memorize all the thing for this properties. I hope you can understand this, because I hope you can try to learn about this. There are a few examples here, because the property of law is very important. We are going to use these properties in the next topic, especially in topic 3, in topic 2, 3, and the last two topics. But now for today, I will show you just a few examples how to use the property of log in your exercise. Okay, just I will show. I will there are please refer to example 1.39. Okay, there are a few examples here. For now example 1.41. Okay, I will show you again how to find the answer. Let's say we have y equal to ln e. to the power of 3x. Okay, how to simplify, how to make it simple. If y equal to ln e t to the power of x, okay, because this part ln e t to the power of 3x, okay, if you refer to the log's properties, the properties of log, any power belong to the domain, for example e, can be written, this power can be, we can call it, we can take this power and put it in front of the equation. Okay, this is equal to 3x times ln e. That the power of the log of the domain can be, we can take the power and then write the power in front of the, before the equation. So where ln e to the power of 3x can be written as 3x ln e. And then what is ln e? 3x ln e is log e of e. Okay, ln e is log e of e. So any log, okay, these properties, the base equal to the value of domain of the x. So this part always equal to 1. So it is a 3x times 1 equal to 3x. That's why, because this equation, we can apply the property of log in the equation. Okay, another example. Example 1.42. 1.42. 1.42. For example, 1.42. We have this equation. 10 to the power of log x squared equal to 25. That's it. We want to find what is x. Calculate x. What is x? Please calculate x. Please refer to page 48 to example 1.2. Okay, how to find x. Okay, in this situation, in this case, what we should do is we must put x, because x in the x in is belong to the power of 10. So since x is in the power position, we need to, we can take log both equation. So this equation can be written as log. We can take log from both equations. Log log 10 to the power of log x squared equal to log 25. We just put log in front of the equation, but we must do this the both part of the equation with the left hand side and the right hand side of the equation. So since the equation in the log form now, okay, this part can be, because in log the power of the x can be written, we can put the take the power and write it in front of the log. So this is equal to log. I hope you all of you can follow what I'm trying to show here. Okay, if you have any questions, you just let me know. Okay, this equal to log x to the power of 2. Let's the power of the log times log 10 equal to log 25. Now, okay, this part, this log 10 is equal to log 10 of 10. Log 10 of 10 always equal to 1. Always equal to 1. So this part you can write again. You can simplify log x squared times 1 equal to log 25. In other words, this is equal to log x squared minus log 25. So, okay, in this case, we can solve this equation very easily because there are two logs at the left and the right. This log has the uh, uh, same base, so we can cancel this out. Okay, that's very simple because uh, we have uh, log x squared equal to log 25. Both of them as a log with the same base. So okay, this part we can cancel out. So this x squared minus x squared equal 25. X squared equal 25. There is x to the square root of 25. The answer is x squared equal to 25. The answer x equal to plus minus 5. Or there are two values here, negative 5 and positive 5. So that is the answer. The answer for this equation. Okay, there's a few examples. The rest example, I leave it to you for your revision, page 48. Okay, the next one. Okay, go back to our okay. The next one is about the graph of the log, how to graph the log function. Okay, there is some properties for log, uh, same to the exponential. There are same properties for some properties for log for exponential. There are guides how to draw the exponential function. Same goes to log. There is a few properties here. Okay, the first one is about the domain. The domain for log function is between 0 and x, 0 and infinity, negative 0 and positive infinity. In other words, uh, domain is x. For log, the value of x must be 0 and above, 0 and above or positive. Thus, the log of non-positive number does not exist. The log of non-positive number does not exist. Okay, that's the domain. What does it mean? Okay, when we draw this graph for log, for example, let's say this for log, the value of x, when we draw this graph, uh, please make sure that we just draw in the region of positive x only. For example, when the graph is only valid in this area where x is positive. The minimum value of x is equal to equal to 0. And then okay, that's for domain for x. And then the second one is about the range. The range is equal to the value of y. What is y? Y can take any number. Y can be positive, y can be negative. Y can take any number from positive to from negative infinity to positive infinity. That's why when we draw the graph, we can draw from we can draw at the positive quadrant of y and negative quadrant of y for the log graph. Okay, that's for y. The log of 1 is 0. The log of 1 is 0. In other words, when x equal to 1, y equal to 0. In other words, y equal to log of 1 equal to 0. it will always equal to 0. So in other words, this graph has what x-intercept when x equal to 1 and y equal to 0. This point, there is x-intercept. For all, the unique characteristic or the unique property of log, any log with in form of y equal to log bx will cross this point at point x equal to 1, y equal to 0. That's the and then the number 3. Number 4 is there is no y-intercept. No y-intercept. No y-intercept. The graph does not intersect the y-axis. The y does not cross the y-axis. The graph does not touch, does not tangent the y-axis. That's why, in other words, there is no y-intercept. Okay. The next one is when b is if b is the base of the log is greater than 1. What happened to the graph? The graph is wise from left to right in the interval 0, 0, negative, 0, positive, infinity. This for example, when the b is positive, when we draw the graph is wise from the left to the right. When x increase, the value of y is also increase when b is greater than 1. But if b is and then the graph is also when b is equal, in other words, when b is greater than 1, when if you refer to the point number 5, but point number 6, the graph approach the y-axis as x get closer to 0. The function value decrease with a bond and the graph get closer to y-axis. In other words, the graph does not intersect the y-axis. As x get close to the 0, what happened to the graph? The graph will get close to y-axis, but the graph will not cross the y-axis. That the another properties of the law. But when the base is between 0 and 1, let's say 0 0.3, 0 0.5, what happened to the graph? The graph falls on the left to right. When the x increase, the graph will decrease. The value of x, the value of y will decrease as x increase. That some properties for logs you can refer in page 49. And then when we draw this graph, we can write this graph, for example, y equal to log 2x, b is equal to 2 is less than 1, or b equal to 1 over 2 less than 1, but much greater than 0. That's for both logs. When we draw the graph for logs, we can have the shape like this in terms of but it depends on whether the b is greater than 1 or between 0 and 1. Okay. The next part is about the relationship between the exponential and log. Of course, there are relationship between these two functions. Okay, just I just want to share with you in brief only. When we have this graph, for example, y equal to bx, and then when we draw the log function y equal to log bx in the same graph, we can see that the graph of y equal to bx and y equal to log bx are mirror reflection of each other. We can assume the linear line is y equal to x as a symmetric line. These both two graphs are mirror reflection of each other. For example, when we have y equal to x as a mirror reflection of y equal to log 2x. But for this log can also equal to x equal to 2 to the power of y. In this case, x equal to the power of y. Okay, same goes to when we draw a graph y equal to e to the power of x and y equal to ln x. Okay, y equal to ln x and y equal to e to the power of x exponential, and the log form y equal to ln x are mirror reflection of each other. This equation can also be written as x to the power of ey, because this is log e of x. There's a relationship between exponential and log function. Okay, I think okay, the last part of for today is about the application of log function. That's very important. We can apply this concept of log in economics as usual in economics and business theory. In this part, okay, if you refer, for example, okay, there is a few example here. Example 1.44, 1.45, and 1.46. Okay, I will share with you. I will show you how to find the to answer the question 1.44. Okay, for this case, let's say I refer to example 1.44. Please refer to uh, page 44, 43, 53. Sorry, 53. This page 53. Okay, this is for this is in bahasa permintaan and penawaran. In English, we can write this as demand and supply. In English, permintaan is demand. In bahasa is permintaan. But for supply, in bahasa we call it penawaran. Permintaan and penawaran, demand and supply. Okay, I will explain this example. I hope you can pay your attention. Okay, let's say given the demand function, Q equal to 18 minus 2p. Q equal to 18 minus 2p. Okay, there is a demand function. There is a demand function. Okay, there is a demand function. There is a demand function in Q in term of P. We call it demand function in term of P. In term of P. So we will. The question is, what is the question? Find the demand function. Find the demand function in term of P. No, not in term of P, in term of Q. In term of Q. Because we have the demand function in term of P. Now we need to find the demand function in term of Q. For example, in term of Q. Okay. So what is the demand function given? The demand function is Q equal to Q equal to 80 minus 2 to the power of P. Not 2p, 2 to the power of P. Now we would like to find what is the demand function in terms of Q. In other words, we need to find P equal to what Q? How many Q? So now, based on the mathematics, we just arrange, we just take the P, put the notation with P at the left hand side, and the other notation, the other term without P, we put in the right hand side. So we can say 2 to the power of P equal to 18 minus Q. 18 minus Q. Now we have P. P in the power position. P 2 to the power of P. 2 with P power. To have the 2 to the power of P. Now we need to find P. Okay, since the P is in the power, we must take log. Let's say for the example, I take a natural log, ln 2 to the power of p equal to ln 18 minus q. Okay, we need to take log both sides, left hand side and right hand side. So ln to the power of p equal to ln times 18 minus 18 minus q. So again, we have this condition here. P, since P is power, is belong to the P, belong to the 2. P is a power of 2. P is in the power position. We can write like this: ln 2 to the power of P is equal to P ln 2 in ln 18 minus Q. So what is P? So we can write P equal to ln 18 minus q divided by ln2. So in other words, there is we can also write this as ln. We cannot open the bracket. So this is the answer. This is the demand function in terms of the demand function in term of q. That's the answer. Okay, that's about the log function. There are a few examples here. I hope you can do your revision, and if you have any question, you can ask me. You can WhatsApp me, and then also you can share your work with me. Okay, any questions so far? Any question?
No question.
Okay, no question. Okay. Okay, the last one for today. Okay. The last, I think we have a few minutes left. Okay, let's say I just want to show you how to solve let's say for equation. Okay, there is one example here. Let's say we have okay, this equation I take from the page 48, example 1.42, equation D. Let's say we have log 2x equal to 5 minus log 2x plus 4. What is x? We need to find what is x. What is the value of x? Okay, so how to find the answer? First of all, we just arrange again this question. We just arrange. We just put the part of the question with x in the at the left hand side, and the rest we put at the at right hand side. Okay, let's say this. We have this one log 2 of x plus log 2 x plus 4 equal to 5. Okay, from this we can write like this. Okay, based on the what we call it uh, based on the properties of log. Okay, because we have two part here, logs with base 2, log base 2 of x and log base 2 of x plus 4, and then there are plus here. So this two equation can be written as log 2. Okay, logs 2. Okay, take in bracket x times Okay, we can write x times x plus 4. Okay, we can write like this one. This is equal to, this is equal to 5. Okay, in this case, we just put in this case. Okay, 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 we have this form now. Log base 2 of x times x plus 4 equal to 5. Okay, please remember that when y equal to log bx, we can convert this into exponential. X equal to b to the power of y. Okay, based from the equation, we have this is y. This is y. We have b equal to 2 and this x. So this one can also be written as x. What is x? X to the power plus 4 equal to 2 to the power of 2 to the power of 5. Okay, this we can open the bracket, we can remove the bracket. This is x squared minus 4x equal to 2 to the power of 5 equal to 32. We can simplify this equation. So what is x? We just can write in terms of quadratic. X squared plus 4x minus 32 equal to 0. So what is x? Okay. Again, now we are in the quadratic situation. We just this is a equal to 1, b equal to 4, c equal to negative 32. So we use the negative b, negative 4 plus minus 4 squared minus 4ac, negative 32, square root all of them, and 2a. You just finish this calculation. You can get x equal to 4 and negative x, negative 8 for the answer. That's how we can relate the log and also the quadratic, because we have the quadratic question here. When we want to solve the x, we find the quadratic equation, we need to use the quadratic formula. Okay, that's one of the example in the text in the my note. I hope you can do your revision and do your homework. If you have any question, you can ask me anytime to WhatsApp, or you can also share with me your works. And if I will check if you share your work, I will check your work, and then I will give my comment whether your answer is right or wrong. Okay, I think that's all for today. Any question?
No, doctor.
Okay, if there is no okay, if there are no question, I think I will stop here. It's quite tired for this afternoon, because I also have another replacement class this morning. Okay, tomorrow I also have two other class. Okay, thank you for your attention. Uh, Next week we have no class next week, because next week is our semester break, and we will see we will continue our lecture uh, after the semester break, maybe the first week of May, and then I hope you can prepare for your for our test, our mid exam. Uh, and then and then the next topic is about topic number 2 and number 3 is about financial mathematics. I will upload the note in the, you can follow as usual. You can download the note. Okay, okay, for attendance, okay, please don't leave this session until I click the button end meeting, and then you will be removed from the meeting automatically by team. Uh, uh, that for I need to do this because I want to record your attendance to I will use the Microsoft Team record for your attendance. Okay, that's all for today. Uh, See you again. And then I hope you do your homework and do your revision, and please be prepared for your for your mid test. Okay, that's all. Good evening and see you.
Okay, see you, doctor.
Bye,
Good
Okay.
afternoon.
See you. Bye bye.
Bye bye. Bye bye.
Bye
Welcome.
bye.
Bye
Bye bye,
bye.
doctor.